Good afternoon or good evening to everybody. Then my name is Moises Martinez. Okay, I'm going to introduce myself. I'm PhD in computer science and artificial intelligence, and I GD in machine learning. And currently, I'm data and artificial intelligence head in a Spanish company called Paradigma, and I'm teacher and research in different universities. During my PhD, I've been living there in Sweden, and I've been in two universities that you have there, in KTH and in the Örebro University, doing part of my research. Then I have good remembers about Sweden. Then after that, we can go to a start about the things that we are going to talk today. It's about machine learning operation, and then we are going to try to discover why we need or we create machine learning operation. What is this? How it's working, and how we can create some loop or some cycle of machine learning operation using the technology that we have in Google Cloud Platform. Then first, I'm going to try to introduce really quick what is machine learning. Okay, if we try to understand how it's working a machine learning algorithm, we try to think how it's working a traditional algorithm, the one that we usually write when we try to solve or create any kind of program. Then this kind of traditional algorithm using an input that usually is split in two groups. One is the rules, which is the source code, the code that we write, and the other is the data. And when we use this information, we can create like an algorithm or a program, and we generate an answer according with the input that we introduce. If we change the rules, we are going to change the answer, and if we change the data, we are going to change the answer too. But when we are talking about machine learning, okay, or artificial intelligence right now, we are changing the structure of this kind of algorithm. When we are using a machine learning algorithm, now the input is not the rules and the data, it's the answer and the data, okay, mostly of the time. Then now we introduce the information that we need to define the rules and the answers that we expecting that the rules generate. Then the machine learning algorithm try to generate automatically those rules that we need to define the behavior of the system. Then this behavior, this group of rules, is the thing that we usually call model. Then the model is the group of rules that we generate automatically according with the data and the answer associated to each data that we use to generate that model. Then depending again of data and answer, we are going to generate a different model. But not only that, depending of the algorithm too, because there are some algorithms that working better than others, depending of the problem that we want to solve. Then, if we try to go inside of that box that we saw before, that machine learning algorithm, okay, we can split it in two kind of algorithm. The one that we call machine learning, the training one, okay, and the second, the serving one, which is the one that we use to deploy the model. Okay, both of them have some input and both of them have some output. But in the case of the training algorithm, the one that we have here on the top, we have answer and data, okay, mostly of the time, depending on the algorithm of machine learning that we are going to use. And after that, we are going to generate a set of rules. And if you remember, I say that the set of rules is the model that we are going to generate using the machine learning algorithm. And when we have that model, we are going to deploy it, creating the serving algorithm, which one we are going to send only data and receive an answer that is quite similar to the answer that we have. This means that we are like learning that group of rules that generate the answer. Okay, I'm going to try to explain what is inside of this algorithm, trying to create in a theoretical way a machine learning algorithm, a machine learning model to choose between apples and cupcakes. Sorry, because there is a mistake there. Okay. Then imagine that we have this big box, okay, and we have the cupcakes and the apples. Imagine that we have some pictures, okay, picture from cupcakes and picture from apples, and we have the data, which is the picture, and we have the label, which is the answer, which is cupcake or apple. Okay, maybe it can be 0 and 1, maybe it can be 2 and 23, but we have to identify any picture, okay, or any group of data with one label, okay. And then when we try to open this big box, okay, to generate the model, we have to do something like this, okay. we have to prepare, to make a preparation of the data. That is something that maybe you review in the previous session, in which you are creating instance of data, in which we have some attributes that can be continuous or can be discrete. And even we have a special attribute that we call label, which is the answer of the data. If this is the data, okay, the different attributes that define that picture, for example, the color, for example, the size, for example, anything that the algorithm is extracting, or maybe you have, we have the label, okay, which is the special information that we use to identify this group of data, okay? And then when we have that label, this label can be the class, can be the label, can be the prediction number if we are talking about regression. But if we are going to use machine learning in a supervised way, we have to have this information, which is the data, and this information, which is the label. If not, it's not possible to do it. It's not possible to run our algorithm. Then when we have this raw data, okay, we are going to do a feature selection. That is the process in which we choose which are the features that we are going to use for training. And we start to generate the different set that we need for our machine learning algorithm. The first one is the training set, which is the most important and the biggest one. Okay, it's around 80 or 90% of the instance of the training data. Okay, after that we have the validation set, which is the one that we use during the training process to validate that the training process is performing well. Okay, this set is really, really important, and mostly of the time don't use it because people don't know exactly how it's working. And it's really useful to analyze the performance of the training process over the different iterations. And finally, we have the test set, in which we put a group of instances which are not in the training set, and we use to analyze or validate the model that we are going to generate. Then once we have these three groups of sets, these three groups of information, okay, we are going to choose the machine learning algorithm, depending of the data that we have, depending of the output that we are going to use, or depending of the label that we are going to put in our data. And this machine learning algorithm can be tuned with a loss function and optimization algorithm and many other things, like, for example, the hyperparameters. Okay, the hyperparameters are some special parameters that we can use to tune the machine learning configuration in order to have better performance, in order to reduce the number of iterations, or in order to increase the speed of the algorithm. Then once we have all of these, we can train our algorithm to create a model. For example, the epochs is one of the hyperparameters that we usually use to run to run our experiment using a machine learning algorithm. Then when we have all of this, we choose a number of epochs for the machine learning algorithm, and we start to training to generate a model, which we are going to evaluate using that text set. Okay, now we are finished the training process. Okay, one training process with the configuration, with all the information, and with the model. And when we have this model, the thing that we are going to do is deploy it, because we want to use that model to generate new predictions. And to do that, the things that we are doing is, of course, using new data, which are not in the raw data that we have before. We use that feature selection because we have to use exactly the same features that we use for training. We can put more feature or less feature when we are going to execute the inference. Okay, and after that, we are going to have an answer. And that answer is a prediction that usually it's one of the labels that we have selected before. Once we have that, we have the two parts of the machine learning process, or the two machine learning algorithms, or the two elements of the machine learning cycles that are important. But now, what is the problem with this? The point is that creating or launching a machine learning model is usually easy. We can create it. But operating that machine learning model, usually it's really, really hard. And why that? Because the big problems with machine learning system appear when we are continuously operating these machine learning models. Because, for example, we are creating that machine learning model, we are training the machine learning model, and we put there in one server for our application, waiting for the user to use it. And then when the machine learning model is used for the user, is starting to fail, then if we don't control that failures, if we don't control that behavior, maybe the application that we created using that machine learning model is not working well. And for that reason, this is the most complex part. And then for that question, we are going to follow this. Why do we need machine learning operation? To try to solve that problem that we addressed before. And if you remember this, the two parts of the machine learning process, of the machine learning cycle, we can put in a big one, which is this, the machine learning life cycle, in which we think that only we have to create the model and only we have to deploy the model. But that is not true, because when we are creating our machine learning system, not model, not machine learning code, the thing that we are creating, it's a lot of steps, a lot of parts that are really difficult to manage, because we have data collection, we have feature extraction, maybe we have data verification, serving infrastructure, because deploying a model is not only putting in a server. There are many things that we have to put there to make it working well. And even we have to monitoring the execution of that model. And if we try to short these different phases or these different processes, we can try to define like a cycle in which we have all the things about the data at the beginning. We have the machine learning process, the one that we did before, that is creating the rules, and all the things related with the model, registration, the data validation for the model, the verification of all of that, and finally, the serving. And all of this have to be monitoring, or maybe we have to define a global configuration. Then deploy or define a real machine learning cycle, it's extremely difficult for our perspective. Then we try to create something that can be used for different machine learning processes. Then we try to group or create a sequence of action or process which allow us to generate like something that we can reuse for different machine learning models. Then the main objective when we are creating these things related with machine learning operation, it's something like a continuous training system that is going to generate a machine learning model or many machine learning models that we are going to deploy in one environment or maybe in more than one environment. Then the point or the bad point is that now we are not doing that. Mostly of the process to create the machine learning model and deploying the machine learning model, this thing that we see, the training and the serving, are totally isolated and most of the time are running manually. Now, when you go to a company, mostly of the things that we do is to create the machine learning model manually. Okay, we are doing a manual data preparation. We are collecting the information from a server and put in our local computer. We are doing mostly of the things in our own computer. And this usually is not really well. It's not really good because maybe we have many problems when we are going to deploy, or we have many problems because the information, the local data that we have is not all the training data that we need, or maybe it's because we don't have the powerful in the computer in which we are going to do the training to execute big experiments to generate good models. Then, to try to solve that, we created machine learning operation. The computer science evolved some of the other operation methodologies to try to create something for machine learning. And what exactly that? Okay, if you are working in software development, I'm totally sure that you know what is this about DevOps. Okay, it's the develop operation, which is the group of good practice that we have to create or to develop good software. Okay, software that we can reuse, that we can share with other teams, or software that it's follow a cycle of generation, testing, and deployment and execution in a perfect way. Then the thing that we are going to try to do in machine learning is try to use this. But the problem that we found when we tried, okay, is that we don't have all the elements that we need in machine learning. This cycle, okay, the typical DevOps cycles don't have data validation, don't have model validation, don't have model deployment, don't have data monitoring, and we don't have, for example, model performance monitoring. Then, to try to include all of these steps and let the machine learning people generate those machine learning algorithms or machine learning models in the same way that we are developing the rest of the source code, the rest of the application that we have, we extended the DevOps methodology to machine learning. And we created something that we call machine learning operation, which is the new group of practice, the good practice that we try to use to industrialize the machine learning model generation. This means that all the things that I explained before, if we want to automatize or productivize, we have to use a machine learning operation process, which include all the new properties and the previous properties of the DevOps methodology. For example, we have continuous integration, but now we have continuous integration not only for code, we have continuous integration for data and model. Now we have continuous delivery, but again, now we have continuous delivery not only for the source code pipelines instead of other pipelines, because now we have machine learning pipelines. And finally, we introduce new properties like continuous training, which is a new one in which the machine learning models can be retrained and serving according with the improvement that they have in that continuous cycle of retraining. And then when we are starting to use that, we starting to observe many challenges that are starting to appear. Mostly of them related with the data, for example, governance of the data, the generation of the pipelines, the continuous training, the data validation, and other related with the productivity. Okay, because when we move a model to production and that model is using for millions of people, we have to think in scalability, availability, portability. If, for example, we want to use that model in a mobile phone or in a traditional computer, and many other things that are really important when we want to automatize or we want to create a machine learning process. And to do that, many advances are going to be appear in the last years in order to create the new tools that we have to automatize the machine learning process or creating that machine learning cycle that is quite similar to the software cycle, but focused in the machine learning part. And to do that, okay, we have this machine learning operation that allow us to unify the development of the machine learning system and all the operation and automation things that we need to do that. And the question is, how is working all of this related with MLOps, okay? To work with this, we have some tools, and especially in the case of Google Cloud Platform, we have Vertex AI, which is a managed machine learning platform that we can use to create that machine learning cycles. We can create all pipelines, we can create all experiment, we can create everything. Even if we want, we can include all the process to generate, clean, prepare, and transfer the information, the raw data that we have for the machine learning training process. And when we are using this platform, okay, and we are using this, or we are creating this machine learning life cycle, we can focus in all the people that is going to work there. It's not only focused for data scientists or machine learning engineers. The machine learning life cycle over Vertex AI is focused to help all the people, all the different profiles that are going to be part in the machine learning cycle. For example, we have, of course, the product manager, because have to get information from the machine learning model using, for example, Looker. And we have to give tools, for example, for the machine learning developers and the machine learning engineers, the ones that are creating the models and the ones are put the models in production. Then with Vertex, we can try, and with Google Cloud, we can connect all of these tools and put it inside of Vertex AI. Then what is Vertex exactly? Vertex is like a framework, okay? It's like a super tool in which we have many tools to follow all the different steps that we have in the machine learning cycles, starting with the data ingestion, okay, moving for the feature engineering, in which we are collecting, identifying, defining all of these different features that are useful, that are necessary for creating our model. We have the training, or even the hyperparameters tuning. We have the model serving, the understanding related with explainability. For example, moving the model to an edge environment if it's necessary, and monitoring and management that model. Then with Vertex AI, we have all of this. It's not necessary to move to another platform because everything is inside of Vertex. And how is working Vertex? Okay, now I'm going to be changing between the slides and between the real Vertex in my Google Cloud platform in order to show how it's working. But the first thing in Vertex is the different options that we have. Vertex offers us many tools related with the generation of different elements, the process of managing the data, all the things related with the model development, okay, and finally, all the things related with the deployment of the models. Then when we are going to work, the first things that we have to see is the workbench option, in which we can create our notebooks. For example, to test the different process that we want to execute in Vertex, or to create the different steps of our pilot, because we are going to use it for both of them. Then when we want to create this, we have to create a notebook, okay, to execute a process. And the thing that we are going to do is to choose which kind of notebook. We can use a customized one in which we define how it's going to be our container, which is the library that we are going to use, or if we want, we can use one of the specific ones that are deploying right now in Vertex. And then we have different kind of technologies, different kind of machine learning tools, and we have different versions of each one. For example, we have the TensorFlow framework, we have the PyTorch, we have R, or for example, we have Rapid, or even the Kaggle Python. Okay, all of these depending of how it's going to be your source code about the machine learning. And then to do that, I'm going to move to my Vertex AI. Okay, then, okay. Here, okay, if I'm my real Vertex, I have different workbench. For example, I created this, okay, in which I create a new notebook using, in this case, a Python one, okay, with scikit-learn. But if I want, I can choose different options. For example, I have version of TensorFlow using GPUs or without GPUs, okay? And we have other kind of different frameworks. For example, PyTorch, okay, or Kaggle or Rapid. The best framework that we can find here is TensorFlow, because it's one that is developed by Google too. And we have the different version here, and we can to execute or define if we are going to install, for example, the GPU's needs. In my case, this one, the one that I created for this talk, it's a really simple one in which I only installing the scikit-learn things, and I'm using a really, really simple machine. Then if I go back to the slides, okay, the things that we have to define when we are creating a notebook is the most important thing is the zone, okay? This is really important because if you put your data in one zone and your notebook in another zone, the things that could happen is that you are going to get extra cost in your Google Cloud platform. Then using exactly the same zone every time, it's really, really important when you are working, for example, with Vertex AI, because there are many information that is moving if you are choosing different zone for this and for the different data set. The other thing that is important is the environment, because you can use a specific Docker container in which everything is installed. And if not, you have to install it and create your custom Docker container. But it's possible if you want to do it. Then the machine, okay. This is the machine that you are going to use to run the notebook. If the notebook is activated, okay, you are running this exact machine, okay, which is the configuration that we have. In my case, it's only 4 CPUs and 15 gigas of RAM. And finally, okay, you can choose, okay, and you can see which is exactly the machine that we have. In this case, my machine is really, really simple. It's an M1, okay, and you can see this information in the information of the notebook. And then one really important thing is the GPUs. If you don't need GPUs to execute your machine learning algorithm, never put one, because it's really expensive and you are not going to get all the powerful that you have if your source, the code that you are generating in your Jupyter lab, okay, in your notebook, is not going to work well. Okay, if you go back to the Vertex AI, okay, the information about the notebook, okay, we can see here, okay, and we have all the information about that. I have the environment, I have the environment configuration, I have the zone and the region in which I have, because for example, in Switzerland zone, there are 3 different, in regions, in Switzerland region, there are 3 different zones, and you can choose some of them. Why Switzerland? Mostly of the new functionality that Google is deploying in beta version are in Switzerland. Then if you want to test anything about TensorFlow or Vertex AI, one of the best areas in which you can test them here in Europe is Switzerland, or if not, one of the regions that you have in United States. And you have all the information about your disk and the type of machine that you are using. Okay, then here you have all the information, the region, the zone, the machine type, and the GPU, the most important one, okay, because this is the ones that are gonna be related with the cost of the machine that you are using to execute this. And you have other options. You can see if everything is working well. You can even monitoring the execution. I ran in and executed some minutes ago when I was testing. And even if you want, you can see the logs. Okay, you have all the information about the notebook, all the things that you did, okay, in your console, or it's here. Then if I go to the notebook, okay, then I can open my Jupyter lab. Okay, I'm going to do zoom again if it's not. Then I have a really simple notebook here. Okay, it's a super simple one in which I created a random forest, okay, using a simple algorithm from Scikit-learn. In this case, the thing that I did is I have some pictures, okay, defining into the data. Okay, these are picture of 64 by 64 pixels, okay, which represent numbers from 0 to 9. This is the typical example that we can find in the different Google pages, okay? And when I try, okay, to train this model using a random forest, I have this matrix, okay, this confusion matrix that gives me how good or bad is my classification. Then here, the thing that I have, okay, is the different labels, okay, number from 0 to 9 and number from 0 to 9. And the thing that I'm putting here in the diagonal, okay, is how many of the inputs that are real zeros are being classified as zeros. And as you can see, not all of them, because we have 42 and one of them was classified like an age. And we have exactly the same in the rest of the cells, in which if we follow the diagonal, okay, we have the number of numbers that was classified well, and the others are the ones that we classify wrong. We have, if I don't remember well, around 35 to 42 that are okay, and you can see that we have some errors from the classifier. And this is the way to generate a simple machine learning notebook, okay, using the first functionality that we have in Vertex AI, which is the workbench. But we have more things, okay? If we go back to the slides, okay, we have other things that we can create, because one good thing that we have in Vertex is that we can create data sets. We can upload our data set and choose which is exactly the data set that we are going to use. In the Google Vertex AI, we split the data sets in 4 categories. The first one, the tabular ones, which are related with the information that you have in a CSV or in a text, in a TST, okay? And after that, we have the special ones. We are divided into image, okay, test, okay, which is related with NLP, and video, which is an extension of the image one, in which instead of picture, we are using a sequence of a video or a shortcut, anything like that. Then to do that, we have to go, for example, okay, I'm going to go to another vertex one because I have different examples. Then here, if I go to data set, okay, I have some data set here. For example, this one, okay. In this case, I was working in United States, okay, not here, let me check. I think it's this. Okay, no, again, a mistake. I think it's this test. Okay, here, yeah. Okay, then I include here a data set for tabular classification, okay, in which I have a group of columns, okay, and I have the distinct values that I have here, okay. Then the good point with Vertex AI is that when I choose what kind of data set I'm going to use, I have to define the objective first. And when we are talking about objective, we are talking about which is the kind of which is the kind of machine learning algorithm we are going to use. For example, if we want to do a classification, we can choose a tabular for binary or multi-class classification. For example, this is a binary in which we have to choose between two different classes, or multi-class if we have more. We have a regression in which we are going to predict a continuous value, or we can use a clustering. And depending of in which area we are going to do that, we are going to do a classification, binary or multi, a regression, or a clustering for every set of data. Then when we are working here in Vertex, okay, and we want to create, for example, a new group of data, we have to choose which is the output, the label of the data that we are going to use. For example, if we are using image, we have image classification with only single label. This means that we are going to classify the image in general, okay? For example, if there is a chair in the image and we don't care about the rest, okay? Or if the image is a chair, we can use image classification multi-label, but for example, we can identify different kinds of chairs, for example, a living room chairs or an office chairs, because maybe both of them can be the same, or for example, a table for an office or a table for a room, and maybe both tables can be exactly the same. Or we can detect different specific objects, for example, here, or we can do a segmentation. But when we are working, for example, with tabular, we can work to create a regression classification, as I explained before, one of these, or even a clustering, okay? And we can do a forecasting, okay, when we are talking about temporal series. Then when we are working about tests, this is more focused in NLP, we have exactly test classification with a single label, okay? We are going to classify a specific word. Test classification when we are going to identify different elements, or we have entity extraction or sentiment analysis. Sentiment analyzing about the test, or we can extract some special information in a test. And finally, we have video, which is the one in which we can make action recognition, classification of video, or maybe tracking some object. All of these are an evolution of all of this. For example, action recognition is an evolution of image classification multi-label, because you are trying to follow one element in, for example, one person in the video to try to classify them. This one, okay, the video classification is exactly image classification, but extended. And the most complex of them is video object tracking, which is a mix between this and this, okay, and even this, to try to extract information about how it's moving one specific object. Then depending of the objective, depending of that label and the data type, you are going to choose one of them. The most simple one is when we are talking about regression and classification, and it's the one that I have here, okay. Then with this, I put it on a small file, okay, with some information about features of houses, because the thing that I tried to predict with this model was the price of the houses in London. And to do that, I created a training process, that I have here. Okay, this is my training pipeline. Okay, using a tabular regression, and I have like 2 hours. I use like 2 hours and 16 minutes to doing that. Okay, and if you want to see what is the elements that I have, okay, we can see now. But meanwhile, I'm going to continue explaining how we can do that. Okay, then we have all the information about the statistic of the data set. Okay, when we created a data set, we don't have a statistic, and we have to generate it after that. Statistics are really, really useful because we can see which is the number of distinct values of if there is missing information to try to identify if the information is okay or not. And when we have that information, that data set, we can start in a training process. And when we are talking about Vertex, we have 2 or maybe 3 modes of training. Okay, the most simple one is the auto ML mode. Okay, it's the one that you can create in your training model. You are not developing any kind of code, and you are just executing with the data one machine learning process that is ruling because of the rules that was defining for the engineers of Vertex AI. And this is really interesting because the thing that you can do, okay, I'm going back to Vertex again, you can see many things like this. When you are finished your machine learning process using auto ML, you are executing something or you are getting something like this. For example, in my case, I generated a model which I can evaluate. This is the version of the model. When I finish one node, I have the training the train, I have the region, I have all the things that I use it to execute it. And finally, okay, I have all the information about the evaluation of the model. Then it's loading again. Okay. Let me see if it's finished or not. Usually, oh, it's not working now. But I go back. Let me, okay, I'm going to try again. Okay, you are going to wait, and I'm going to continue. And if you want to do something more complex that is not only with auto ML, you can go and creating your own machine learning model, your own machine learning code, creating your script, creating your file, creating your notebook, and execute it in Vertex AI. And that is the one that we call custom expert mode, in which we train models using the framework that we want. For example, using TensorFlow, or for example, using PyTorch, or using another kind of framework that you want. And the good point is that you can choose many of the configuration of the process, because you can define if you are going to execute in a GPU, you can choose if you are going to execute with a specific configuration, or even if you want, you can create the container, the Docker container that you are going to use to execute that. That is the good point, but you need to know how to create all the code related with the machine learning process or the machine learning training and deployment. Because if you are not good coding in TensorFlow or maybe in PyTorch, maybe your mod is the auto ML, which is going to execute really good model, not using a lot of time, and the cost is not really bad. Okay, then if we go back to see the output, okay, we are going to see, yeah, here. Okay, one interesting thing that we can do when we evaluate a model is to see what is the output. Now, the thing that I tried to do was to create a regression, a linear regression, in this case, a multilinear regression model, okay, to try to define or try to predict which is the price of one house, okay, and this is the typical metrics that we usually use in regression. For example, the mean absolute error, the mean absolute percentage error, the RMSE, and different ones. And we have here something that is really interesting when we are using auto ML, is the feature importance, because this means how important is the different features that we have in the data set to create the model. If we see these, the quality, the global quality of the house, okay, or the flat or the independent house is one of the most important things. And the importance is around the 20%. After that, we have the ground living area. After that, we have the total basement floor, the year in which the house was built. That is really, really interesting, because once we are creating this model, the thing that we can do is to try to remove some of these other features that are not really, really useful or are not important, as we can see, and only creating a model using this, because are the important ones according with the distribution of the data, which is really, really useful. And besides, we can do other things. We can do a batch prediction. Okay, I can load, for example, some example here and create a batch prediction, or even if I want, I can deploy into a container, okay, the model that I created with AutoML. Then the good thing, so the good point for Vertex AI is that depending on my level of knowledge, or for example, my profile, if I data analyze, I'm machine learning developer, or I data scientist, I can use one of them. For example, if you are a machine learning developer and your background about machine learning is really high, the thing that you can do it is go to the Vertex training. This is the custom mode, okay, in which you are developing your own algorithm, and you can move and create something more complex. If you are a data scientist, one recommendation is to use the AutoML, in which you don't need to know about how is working the model, how is working the training algorithm. You don't need to focus in that part. But even if you are a machine learning developer and the only thing that you want to do is to make a simple model really quick, or testing if the data it's okay or not, you can use AutoML. But we have another extra feature in Vertex AI that was appeared some months ago, 1.5 years ago, mostly, and now it's really, really useful, is the BigQuery machine learning, in which we can create some kind of machine learning models by a query in BigQuery. This means that we can create an SQL query introducing some special function that allow us to create a machine learning model, a prediction over the information that we are getting with the query. And this is really, really interesting. And it's running over the infrastructure of Vertex, but not directly in Vertex. Okay. And finally, when we have all that information and we have the model, we can create it an endpoint. And the endpoint can be created using the AutoML models or using the custom models, the ones that you created with Vertex. It's not important if you are creating the model using this mode or if you are using this mode. You can use exactly the same dashboard, the same system for the endpoints, which is really, really useful. And okay, finally, one point that is interesting to see is that, okay, all of these things that I did here are something like manually. And if we want to create a real machine learning process, a real MLOps process that follow all the machine learning cycle, we have to include something that automatize that. And to do that in Vertex, okay, we have something that we call pipelines. Okay, the pipelines are like a sequence of process that allow us to generate all the different steps that we have in the machine learning cycle, starting with the development of the basic code of the machine learning until the prediction serving process. If we want to do this with Vertex, the things that we have to do, it's using the different functionalities that Vertex have. For example, we can use Vertex pipelines for all the process of execution and deployment of the model. We can use Vertex feature store. For example, if we want to create a feature store about the data that we are going to use to train the model. Okay, and finally, we can use Vertex monitoring in combination with prediction serving, okay, to get all that information about the different things that are happening in our model. And how is working Vertex pipeline? It's really easy. It's based in Qtflow, okay. That Qtflow was a technology that Google is starting to use like 6 or 7 years ago. And at the beginning, we have to create the pipelines in a more manually way. But now we can create pipelines in a really simple way, just like a small diagrams in which we define what is the thing that we can execute in the pipelines. For example, we can choose a notebook and we can choose the order and the connection between the different steps. which is really, really useful. Then, for example, I have one task that is writing to Google Cloud Storage and another that is testing, okay, one model from the information that I have in Google Cloud Storage. And for example, the information that I'm generating here, okay, it's the confusion matrix that we saw before, okay, but in this case using the interface that Google has. And the good point of the pipelines is that we can govern and monitoring all the process that we are defining here, and we can track the artifacts, the different models and group of data and data set that we are creating. We can have a lineage of the data set, the feature store, and different elements that we are creating, and we can generate metrics about the features of the model and the different experiments and the output. Even if we want, we can include some information and metrics about explainable AI, which are something new that we can find here in Vertex AI with some really, really nice algorithms, not only for tabular data, like in the other clouds. And finally, the process that we are creating when we are executing a pipeline, it's something like this. Okay, we are putting an experiment that is running a pipeline in which we have different steps: the data preparation, the feature engineering, the model training, and the model evaluation. And we execute this pipeline using a source code. And then this, okay, the experimentation, it's executing, running the pipeline. And this is all that I want to talk today. I'm close to the time that I have, okay? Then if you have more questions, you can send me an email, or you can contact with me in the different social network, or asking me now if you want. And thank you so much. And I don't know if there is any question.
Thank you. Thank you for your great presentation. It was really great.
Then thank you so much. It was really, really nice to share with you all these things. And I don't know if someone have any question, curiosity, or anything about Vertex AI or the different things that we can find in Google Cloud.
I do have a question, Moy. Maybe since you were trying to convince us with the wonders of Vertex AI, could you give us some numbers? I mean, if there is someone that decided to use it at the company, or they want to create a startup,
Okay.
just to have a rough idea, do you pay for different models or for the transactions, or how much can be a year? I don't know, to monitor. Yeah, something like brief idea.
Yeah, this is a very, very good question. For example, the model that I created here, this one uses Auto ML. Okay, I think I pay like $5. Okay, and most of the thing was automatically. The only thing that I did was putting my data set, choosing the output of the model, and running. And I have that. Okay, it's not really, really expensive. Okay, but for example, if I want to execute a pipeline, okay, everything is related with the time, and everything is related with the machine type. Okay, if you are choosing a small machine type like I have here, okay, you are paying not a lot. Okay, and if you are, for example, using what with GPU, the price is really, really high. To give you some numbers, for example, this notebook, okay, this simple notebook, if I execute in the machine in which I have the notebook, a really, really simple one, I think that is here, okay, I'm going to pay for 24 hours, 7 days, during 31 days, okay, around $125 using this machine all the time, 24/7, okay, during 1 month. Okay, if I want to execute this, which is a lot, we don't usually need that. And the other thing that we have to take into account when we are using Vertex is the deployment. Okay, if, for example, we have serving an endpoint, okay, that is working 24 hours 7, the price is starting to be high and could be around maybe 300 euros per month. Okay, and if you include, for example, the explainable AI system, maybe can be around 500. Okay, and always, and again, depends of the machine that you are going to use. Then if, for example, you want to use Vertex AI in a medium-sized machine for 1 year, or and you have the model 24 and you have a model 24 hours per day, okay, a full day, like during the full year, maybe we are talking about 8,000 euros, 9,000 euros with training, retraining, and deployment. This is around the price that you can have in a company. And this is if you are not doing anything. You put there the process and it's working 24 hours every day. But usually when you are using machine learning operation, you are not doing that. You're executing, for example, the training process only 1 day per week or only 1 day per month. And maybe the endpoint, it's in a super small machine and it's only running 8 or 9 hours per day. Then if you do that, maybe the price can go around 2,000 euros, 1,000 and a half, depending on the configuration. But of course, depending on the machines, again, this is Google Cloud Platform, and the thing that you are paying is the computation time. And depending on the time and depending on the size of the machine, you are going to pay more or less.
We have a question. Daniel asked how to expose the model as an endpoint. It's like deploying the model.
Yeah, you have two ways to deploy the model. Okay, you can do a batch deployment, which is the thing that we call batch prediction, things that we have here. That is something that you executed in, for example, every Monday, and you save the output in, for example, a BigQuery, and then you ask to BigQuery for the prediction during that week. And the other thing is the endpoints. The endpoints is a real-time endpoint. Okay, it's like you deploy a server, a web server with an API, and you can ask to the API in real time for a prediction and get a result. Okay, both of them are quite the similar thing because both of them are working with an API, but this is to deploy a model in real time, and this is to deploy a model in a batch process. It's exactly the same when you are talking about batch ingestion or batch processing and real-time processing. And you can do both of them because the model is here in the model registry. Okay, not in this, sorry, here in the model registry. Okay, I have a model here, and you can deploy if you want like an endpoint, or you can make batch prediction even during the pipeline. You can create a pipeline that execute the batch prediction or deploy the model every 3, 4, 5 days according with the training loop that you define.
And he asked, can you run on spots or serverless?
Yeah, exactly. You can run serverless if you want. Okay, it's possible. Okay, and depends again of the configuration that you want to do. For example, I can create an endpoint. Okay, can be a standard, can be private. Okay, I'm going to choose. Okay, that's one. Okay, and even if I want, okay, I can choose more things. And here I can choose, for example, the model. I can use the version that I have, and I can define the traffic split. And according with the traffic split, okay, the system is going to work in serverless or not. If you are putting a lot here, okay, you can use more or less depending on that. And now, if I press done, okay, I can deploy the model. It's maybe need 3 or 4 minutes to be there. And once it's configuring, it can work in like an serverless or not. And if you want, okay, not in this case, when you are, for example, configuring your Kubernetes system, you can configure to increase or decrease the number of versions of the model that you have, for example, to control the use of the model. Thank you. It was a pleasure to be here.